Hmm. Here we see the heat balance sheet. In the heat balance sheet, we will first see the energy input or heat supplied. Heat supplied is QS into m dot F into CV. That is the energy input or heat supplied in the engine. That is mass of fuel into calorific value of fuel, and it is we taken as 100%. Okay. This is the input. Now we have found output. Output is equal to heat loss in brake power. The BP into 60. Brake power we can measure from any dynamometer and put value here, and we get heat loss in brake power. This is useful power. Okay, the heat loss is useful heat loss. This value is 25 to 35%. Heat loss in jacket cooling water or heat loss in engine cooling water. Some books use jacket cooling water, some books use heat loss in engine cooling water. So that is mass of water, CP of water, and temperature difference of water. The value of CP is 4.187. This value is come out to be 30 to 35%. So Q1 percentage obtained Q1 by QS. This percentage is obtained Q2 by QS. Okay. Now heat loss in exhaust gases. Heat loss in exhaust gases is mass of exhaust gases, CP of exhaust gases into temperature difference of exhaust gases. Okay. Heat loss in exhaust gases when percentage of H2 is not given. If percentage of H2 is given, then heat loss in dry exhaust gases. Here, instead of heat loss in exhaust gases, the word comes heat loss in dry exhaust gases. That is MDEG, and heat loss in steam. Number 4 is heat loss in steam. If H2 is given only, then okay. So first we find heat loss in exhaust gases. H2 is not given. So Q3 is mass of exhaust gases, CP of exhaust gases, and temperature difference. This value is 35 to 40%. Q3 by QS. Okay. So there are three cases. Okay. That is when MA and MF are given, then mass of exhaust gases is mass of air, mass of air upon mass of fuel. If you mass of air plus mass of fuel. Okay. If you remove common mass of fuel, then mass of air upon mass of fuel plus 1. Okay, mass of air upon mass of fuel is air fuel ratio. If air fuel ratio is given, use mass of exhaust gas is equal to mass of fuel, air fuel ratio plus 1. Or if it is mass of air, mass of fuel is given, directly use mass of exhaust gas is equal to mass of air plus mass of fuel. Okay, that is heat loss in exhaust gases. That is the first case. That is A. B is that is the first problem A. And the second problem we will see this. When volumetric analysis of exhaust gases is given, then mass of air upon mass of fuel is equal to NC upon 33 C1 plus C2. Okay, put in percentage form. Put in percentage form. N is percentage of N2, C1 is percentage of CO2, C2 is percentage of CO, and C is percentage of carbon. Put all these value in percentage form. Put in percentage form. From that we get mass of air plus mass of fuel. Put in the case 1, we get mass of exhaust gases because the air ratio is known. Okay. Third problem we will see on this. When exhaust gas calorimeter readings are given. This is the exhaust gas calorimeter. From the engine, the gases are flowing to the exhaust gas calorimeter. This is heat exchanger. Okay. This is exhaust gas from the engine. This is TG. This is exhaust gas out from the exhaust gas calorimeter. That is TGE. Okay. Exhaust gas out. This is cooling water in. TWI. Cooling water in. Okay. TW dash WE. That is cooling water out. Because cooling water inlet from exhaust gas calorimeter or engine cooling. That is the temperature is same. That's why I am using the notation is TWI. But outlet temperature is different. That's why I am using dash here. TW dash or TWE for engine cooling. And this is for exhaust gas calorimeter out. Outlet water for exhaust gas calorimeter. So this is the cross flow heat exchanger. It is reject heat. Exhaust gases reject heat. It is taken by the cooling water. Okay. So mass of exhaust gases, CP of exhaust gases into temperature difference of exhaust gases. This is the heat rejected from the gases equal to heat taken by cooling water is mass of cooling water, CP of cooling water into temperature difference of cooling water. From that we get mass of exhaust gases. Put in this equation, mass of exhaust gases. Okay, we will get Q3. We will get Q3. So and Q3 is Q3 by QS equal to percentage in percentage form. Okay. Mass of water is measured by 1 liter jar. If you measure this flow rate with the help of 1 liter jar, for 1 liter how much time is required, and 1 liter equal to 1 kg for water. From that we get mass of water. Okay. So from mass of water we will this is now heat loss, but here the word is dry. We are dry exhaust gases when percentage of H2 is given. So there are two come H2 and heat loss is come always with H2. Okay. So this is Q3. Now Q3 is not Q3 is again when percentage of H2 is given, we can write Q3 is again mass of dry exhaust gases, CP of gas, Tg minus Ta. This is again mass of air, mass of fuel at m dot f is equal to mass of exhaust gas, mass of steam, and this is mass of dry exhaust gases. So mass of dry exhaust gases is equal to mass of exhaust gases minus mass of steam. This is the equations for burning of H2NO. Okay, for 2 kg, 16 kg and 18 kg of steam is required. For 2 kg of hydrogen, 18 kg of steam is required. For 1 kg of hydrogen, we require 9 kg of steam of water. So we can from that mass of steam is equal to 9 into H2 into m dot f. From that formula, we can calculate mass of steam and put the mass of steam is here. Mass of exhaust gases from any three gases ABC, we get mass of dry exhaust gases. Okay, mass of dry exhaust gases. Okay, so Q3 is mass of dry exhaust gases or Q3 is mass of exhaust gases depending upon H2 given or not. If H2 is given, here is word mass of dry exhaust gases. If H2 is not given, here is word mass of exhaust gases. Okay, if H2 is given, the mass of dry exhaust gases and plus steam. So again, steam is heat carried by steam. Heat carried by steam in exhaust gases. How much steam is carried? The mass of steam, H of steam into H of water. So H of steam is calculated Hg plus Cp T sub minus T sat. But this is at partial pressure of steam. So partial pressure, if it is not given the numerical, we can assume 0.035 or 0.04. We generally assume 0.04 bar. At 0.04 bar, we can calculate. We can from the steam table. We can find out the value of Hg and T sat from the steam table. So this is from the steam table. This is from the steam table. The Cp of steam is 2.1 and T sub means Tg, temperature of the gas. So because gas and water vapor living at the same temperature, that's why we can directly get this 3G. Okay, from that we can calculate Q4. That we can calculate Q4. Now, if mass of oil, Cp of oil, and temperature of oil is given, then you can write heat loss to piston cooling oil. If it is not given, otherwise, not right. This is 0. Okay. The heat loss to piston cooling oil is Q5 is equal to mass of oil, Cp of oil into temperature difference of oil. Okay. Now, last one is unaccounted heat loss or loss due to radiation or friction, etc. So we can write Q6 equal to Qs minus all this brake power, engine cooling jacket, heat loss in exhaust, dry exhaust gases, heat loss in steam, and heat loss in piston cooling oil. So this will get Q6. Now this is important. This is for 4 marks. You can draw this input and output table. This is heat supplied kilojoule per minute. That is QS. Okay, it is 100%. It is 100%. Heat loss in brake power. That is Q1. For SI engines value near about 21 to 28%. For CI engines 29 to 42%. Heat loss in engine cooling, heat loss in jacket cooling water or engine cooling water. That is SI engine 12 to 27%, CI engine 15 to 35%. Heat loss in exhaust gases 30 to 35% for SI engine, 25 to 45% for CI engine. Heat carried by steam in exhaust gases for SI engine 5 to 12%. For CI engine also 5 to 12%. And heat loss due to piston cooling oil, we don't know these values. Okay, and here unaccounted heat loss, it may be 3% up to 55% and 21% up to 0%. Okay, so from this we can this is 100%, this is 100%. Okay, so this is this table is important. Okay, for at the end of each problem you can draw this table even in lab also. If you do the performance, we can also draw this at the end. We can also draw the heat balance sheet for the experiment in diesel engine and in petrol engine also. Okay, we are in petrol in lab is petrol engine, diesel engine. So we can measure the various parameters, calculated the performance and heat balance sheets, and at the end we can draw at the end of the experiment we can draw this heat balance sheet and compare the results. The most important power is brake power. Okay, we are interested in brake power, and all these are losses. All the jacket cooling water, digestive gases, steam, piston cooling oil, okay, or radiation losses. All these are all the losses. Okay, so this is all about the heat balance sheet. Okay, you must remember all these formulae. We will see the numerical on each cases A, B, C, and in dry exhaust gases. Okay, with the okay, okay. Then thank you so much. Have a nice day.